Now let's move on to data frames. Like matrices, they can be created from vectors. But here's the interesting part. We can also create data frames from matrices and the other way around. However, there's a key difference between data frames and other data structures. And that is the fact that data frames can hold different data types in different columns. To illustrate this, let's look at an example. I'll start by creating a simple vector called x, which contains the number from 1 to 10. From this vector, we can create a matrix by passing x into the matrix function and specifying the number of rows. Let's give it 5 rows. And here we go. We have our matrix. I'll clear this for now so we can focus. Now, when it comes to data frames, the process is slightly different. Unlike matrices, data frames don't require you to specify the number of rows. Instead, we use the data.frame function. Let's create one now by passing x into data.frame. The result is a data frame with one column. To make it clearer, we'll name this column colhex. If we place a comma and press tab, we'll see a list of additional arguments we can pass. Notice that number of rows isn't one of them. That's because data frames don't need it. But as mentioned earlier, we can also create a data frame directly from a matrix by nesting it inside the data.frame function. Doing this gives us a data frame with two columns, x1 and x2, automatically named. That's helpful. But let's return to our original plan, creating data frames from vectors. We already created one data frame with colhex. Now let's add another column. I'll create a new object called y and assign it the letters A to J, a different data type. If we try putting x and y into a matrix, let's see what happens. We'll get an error or a correction warning. That's because matrices can only contain a single data type. In this case, I will requires all the values to characters to maintain consistency. But with data frames, this isn't an issue. Let's pass x and y into data.frame and assign them to colhex and coly respectively. Now we have a proper data frame with two different data types, integers and characters. I'll store this in an object called dt, short for data. Now we can start exploring some of the properties of data frames. We can check the column names using the colnames function. It returns colhex and coly. What about row names? Our data frame doesn't have custom row names, but we can retrieve the defaults using row names. For now, it's just 1 through 10. To inspect the internal structure of our data frame, we can use the str function, short for structure. Running strdt gives a compact summary. We see that our data frame has 10 observations, that is 10 rows and 2 variables or column. Each column starts with a $sign. That's because the $sign is used to access specific columns in a data frame. More on that later. For now, look at colhex. It's made up of integers, and coly contains characters. So data frames, unlike matrices, can store multiple data types in a single object. We can also perform operations on data frames, but it's not always as straightforward as it is with vectors or matrices. For example, let's multiply a numeric matrix, say my maths, by 2. The operation works as expected, but if we try the same operation on our data frame, dt, we get an error. That's because dt contains both numeric and character data. And how does it know how to multiply characters? To perform operations on a data frame, you need to target either specific rows or specific columns. Ideally, ones that contains the data type that you'd like to operate on. And that brings us to our next topic, how to access and manipulate elements in a data frame.